Welcome to the 39th episode of the New Ventures podcast. I'm your host, Sanjoy Sanyal, the founder of Regain Paradise, a boutique climate consulting firm and a visiting fellow at the Cambridge Judge Business School. I host the New Ventures podcast to help people starting climate initiatives to learn from practitioners who have been already progressed in these paths. Have you ever wondered if it is at all possible to predict how climate change will affect the business you are in 30 years from today? You can actually make a good guess using data, scientific studies, and artificial intelligence. To discuss that, our guest for today is Iggy Bassi, founder and CEO of Cervest, a company here in the UK, which is working on climate intelligence. Welcome, Iggy.
Thank you very much, Sanjoy. Thank you for having me on your show.
Iggy, we'll break up this conversation into three parts. First of all, obviously, because it is a complicated topic, we'll spend some time in understanding your offering. And then we'll talk a little bit about the applications, how people and customers actually use it. And then because your company is so unique and interesting, we'll spend a little time about your own business and values. Let's start by understanding your offering. Your EarthScan system starts with what you call assets. Let's just understand what this word assets mean.
Yeah, absolutely. So we are very concerned about the impacts of climate change, climate breakdown, climate crisis, climate emergency, call it what you will. But fundamentally, the manifestations of that will impact our assets. And what we mean by assets, there are three broad classes of assets. So we're very concerned about built environment assets. So think buildings, warehouses, water treatment centers, hospitals. A second class of assets would be linear infrastructure. So think road, rail, network, pipelines, grid, for instance. And of course, this third category of assets are natural assets. So think forestry, greenland, pastures, farmland. So those are the three broad categories. Anything that really generates our social, financial, ecological returns, that's essentially what we focus on, because that's where climate impacts will affect our relationship with those returns. And also, what actions do we need to take to protect those returns longer term?
And to understand impacts, you use both peer-reviewed science and remote sensing. We will try and understand those a little bit. Maybe remote sensing is easier to understand, so we start there.
Sure. I think there's a collection of technologies. I think the world has moved on fairly drastically in terms of our ability to collect data, synthesize data, process data, and start looking for new patterns that were not possible, but at price points certainly weren't there 5-10 years ago. If you look at computational cost, if you look at the cost of imaging. But I think if you break the problem down into three broad categories, there is compute, there is data, and there are algorithms. The cost of compute has come down. It is available. It will be a service on demand like everything else. Data is a bit more complex, but there's a lots of heterogeneous data. There's data across different spatial temporal dimensions. There's data at an asset level. There's data at a country level, at the grid level. Over time, we're going to see more and more availability of data, more and more granular data, and data that can start looking at sort of intricate details of assets, intricate measurements of climate. Then that leads us with a third category, which is really looking at algorithms. How do you fuse together? How do you use the power of compute with all this complex data? And this is where you do need to think about novel approaches to machine learning, asking questions, computational statistics, understanding the individual hazards that are likely to impact hazards. So in many ways, data, compute, and algorithms need to work together. But over time, I think the advantage will probably go to how can we better measure risk at a granular level using smarter algorithms.
We'll talk about algorithms, of course, but just on the data thing, you alluded to the price. Are these sources all public? And then, of course, the big question is, how do you examine the veracity of the data?
If we take two broad classes of data, if we take climate data, for instance, we only use peer-reviewed science. And that's fundamental to us because most of the world's decision-making capabilities are calibrated on things like ERA5 or CMIP6, IPCC sort of generated data. For us, it's important that we use that baseline because many people base their decisions on that and also setting their goals next to that. However, when it comes to data sets that are publicly available, they're often available at very high resolutions, scales that are not really asset centric. So they're not that decision useful other than measuring high level trends over large areas. This is why we have to use interesting methodologies and novel methodologies to start looking at things like downscaling, whether that's sort of physically aware downscaling or higher resolution imagery. Higher resolution imagery is still very, very expensive. If you were to get a global footprint of assets, one, I don't think it's available everywhere, but two, it'll be very, very expensive endeavors. Then you need to use statistical methodologies. How can we take 10, 20 meter resolution imagery right down to the asset level? The other big data is really asset level data. Now, the world has been labeling data for many decades. Obviously, Google has helped and many other large companies have helped. So we gather data both from public sources, open sources, private sources, paid for sources. So I don't think there's a clean data set that anyone can say it's available for all the world's, let's say, building, natural capital assets. Most of our time on the engineering side is cleaning up that data, labeling that data, and really understanding what are the different attributes of that data. Just to go back, it's really important that you understand there's a profusion of data. There's a lot of data available. There's a lot of science available. Go back to the concept of compute and data. Question is, how do you synthesize that together at price points that make sense? We're also then driving towards the veracity. What's the best estimate of probability we can give to our users, our customers? Remember, people are making business decisions, investment decisions, adaptation decisions. So your ability to really forecast, but show the uncertainty in that data is fairly fundamental.
Okay. And then you mentioned peer-reviewed science. And then my question is, global climate models have become very good at predicting average Earth temperature. But how good is it in measuring, say, the impact of a natural forest in a specific location?
Yeah, so this then goes to the heart of how do you then use smarter algorithms to get down to specific locations? And also there's just a class of models. So there's not a single model. We use lots of ensembles of models. So look at things like Cordex. There is some downscaling that's already happened, that's already embedded in some of these models. But if you were to take something like flooding, for instance, you have to be able to then integrate global flooding models with hydro models. So you can look at the different processes, different conditions, different catchment areas across regional flooding. In many ways, you've got to get to this very high spatial resolution. You need to be able to simulate things like water flows, topology. So you have to sort of develop digital terrain maps, for instance. You have to start using machine learning techniques to say, okay, how do we get a better signal which is closer to the asset level? Because you're right, it doesn't come out the box, and therefore it takes a fair amount of work, both engineering, machine learning work, computational statistics, GIS work, to stitch all this together in fairly novel ways to give fairly unique insights for the first time.
Okay. And this is probably the time we really need to understand the use of algorithms, in particular machine learning algorithms. I think everybody who knows the word machine learning knows that it's about making computers learn from patterns and then helping them spot patterns and predict things. Maybe you can explain, what patterns your component has learned from and what can they predict.
Yeah, Earth science is trying to make the historic Earth system models more accurate, better, reflect many more variables so we can understand the interrelationship between the variables. In many ways, you're trying to represent as much of the physical world as possible within your modeling framework. You need to be able to move away from single hazards. I think univariate modeling is useful. It's got much, much better. But actually, the world is really exhibiting patterns where you need to be able to measure multivariate risk over multiple timeframes under different emission scenarios as well. Machine learning can help fuse together different models, different variables, different physics approaches, different spatial temporal resolutions in fairly unique ways to be able to give greater resolution at the asset level to make it more decision useful. Machine learning, like everything else, is just a great tool. At the end of the day, can I give somebody a better ability to make a decision? The outcomes are very important as well. There's different classes of machine learning we use, everything from GAN to computer vision, I think all the usual classes. It's the interdisciplinary nature of this problem, Sanjoy, that allows us to get a better signal of what we call climate intelligence. I think what really matters here is how decision useful is the outcome that we're giving for people to make that decision. So we ultimately want people to make low regret decisions, because that's the first wave of buy-in, to say, I'm looking at your predictions, I'm looking at my risk on my assets. Can I make some early decisions? Can I think about low regret decisions first? And then as I get more comfortable with these risks, as I can correlate this risk to my business patterns, can I take more bets? Can I make better business strategy decisions, for instance, like should I be buying this company? Should I be building a new factory in location X? Or what's going to happen to my existing factories from a EBITDA cash flow point of view, from a valuation point of view? How much value am I likely to lose over time? The word machine learning is very big, it's very broad, but there's lots of classes of classical statistics, computational statistics, physics models, ecological models that feed into that broader category. I think machine learning can help reveal the magnitude, the timeframes of climate impacts a lot faster with greater accuracy and over more space. We can start modeling very complex portfolios that sit in multiple countries through machine learning, which is quite difficult to do with historic models. So I think there are limitations to existing models. They're just never been computationally efficient. So we've tended to take very small samples. I think that's all changed. I think high performance computing can fundamentally change that. We can build new classes of models where you can encode the laws of physics into those modeling frameworks. So there's less bias. They are more reliable, but ultimately they're more decision useful. And that allows us to really build a new class of earth science models for the very first time. So we can deliver greater frequency of decisions, greater analysis. You can compare larger spatial temporal scales. But also, more importantly, you can start interconnecting physical sciences with impact sciences. This is everything that the world of science is telling me. Now I can map that onto the financial impacts, the actual impacts that are going to impair my assets. And that's going to be a big change over time as well, because the world needs to encode as much of the science world into business language through the use of climate intelligence.
The world needs to uncode the scientific language into business language. I think I couldn't agree with you more there. What I'm trying to figure out is, in order to predict the future, the system must learn from the past. In your case, it's the systems are learning from the past climate data, is it?
Partially, I think it learns the patterns. There is some signal, but it's not pure regression in the sense that you can just draw a straight line of what's happened in the past. And this is where the ability to decipher multiple physics models and re-represent those in a machine learning framework becomes very, very valuable, because there's no straight line in climate, as you know, and there's no straight line in any single variable. There's some patterns, there's some signals, but the ability to break those down, again, this is why you need a research team. You need to be able to decipher all these various models and say, well, every time we see this pattern, we are likely to see these other hazards as well. So if you have excessive heat, for instance, it's a precursor for things like drought. It is a precursor for things like wildfire, for instance. So it's the interconnectivity of these hazards that ultimately matter today. And I think they matter with greater urgency and frequency. But I think new machine learning frameworks, high performance computing are allowing us to synthesize these different variables in ways that we haven't been able to do before. So we can measure things like compound risks. We can look at multiple risks simultaneously over many different geographies, many different assets, for instance.
Absolutely. Which is why there's no one path, no linear path, which is why climate change, they use this called scenarios, right? And that makes it even more complicated, because these scenarios are not just physical scenarios, they're policy scenarios. Whether the policy is orderly, disorderly, quick, fast. I mean, I guess that makes it complicated. And perhaps if you can help us understand how you model that uncertainty, be helpful.
Yeah, absolutely. So there are two broad areas that policymakers and sort of regulators sort of asking us to look at. If you were to break them down into two broad classes of models, first of all, there are models looking at physical risk or sort of biophysical characteristics. And these are really assessed through generating scenarios, which are really built on the back of Earth system models. That looks at the sort of complex tapestry and interaction between oceans, land, ice, the biosphere, for instance. So we can estimate that the sort of changing climate patterns longer term. And then that feeds into multiple scenarios to say, under a high carbon world, a low carbon world, a Paris aligned world, etc. Then you can pull out different scenarios to say, actually, we expect these biophysical characteristics to change faster or slower under different scenarios. There's a second class of models which are really looking at the transition risk, which are really inputs you need from things like the energy system, macroeconomic modeling, land use changes. These are really generated historically from integrated assessment models, or IIMs. Both need to work together over time because both can start informing policymakers, decision makers, investors on what are the physical characteristics and then what are the policy changes. Are we likely to see an orderly world, a disorderly world? Will prices change fast? Will they change suddenly? Will technological change be fast? Will it be slow? Will there be greater dispersion over time? Will there be a sharing of technology? It's also factoring many sort of socioeconomic variables as well, things like population growth, energy usage, per capita usage. So these are deeply complicated two classes of models that then have to come together so people can make everyday decisions, whether you're a policymaker, you're a bank, asset manager, insurance company, you're a community manager. These are deeply complicated problems, Sanjoy, because you're sort of dealing with biophysical characteristics and you're dealing with policy, behavioral change, technological change, cost structures, absorption rates of sort of different technologies. So they have to come together, and there's no such thing as a supermodel because it just doesn't exist. And it'd be very difficult to take what are essentially policy decisions alongside biophysical decisions, which are kind of natural processes.
Absolutely. And this is why it is so difficult to model out. One thing I wanted to pick up a little bit on, what you already mentioned about hazards. It is not one type of hazard, very clear. My question is, hazards in what time frames? Obviously, a hazard in 10 years time frame, in 20 years time frame. What can you predict?
First of all, the classes of hazards that most climate tech companies are focused on are very much around hazards that cause physical damage, first and foremost. And so if you take flooding, so there's different classes of flooding. There's riverine, coastal, fluvial flooding. Heat is actually a primary driver. Changes in temperature. Heat is obviously the sort of underlying driver for so many other hazards. We obviously look at wind patterns, precipitation patterns. We're now looking at wildfire. We look at drought. All these are fundamentally biophysical changes which are changing to such an extent that they have to be modeled to understand the impacts on individual assets or even on sort of policy decisions. So hazards in terms of timeframes, just to your question, they're very variable. In fact, many of these hazards have already happened. They continue to happen and they'll happen in the future. What climate modeling will really tell you is, well, how much have they happened in the past? Do they happen together? Do they happen simultaneously? Are these discrete events? Where are we with these hazards today? And are we likely to see an intensification under different carbon scenarios or under different GHG scenarios, for instance? Can we estimate something in 5 years' time, in 10 years' time? Of course, our goal as a climate intelligence company is to say, well, these timeframes need to be mapped onto decision useful or business relevant timeframes. So if you're an insurance manager, you need to know over the next 4 quarters, but you also need to know the longer term trends. Where are we likely to see more density of risk? Can we design better products? Can we start linking adaptation with physical risk, for instance? Can I tell Sanjoy, these are the types of actions you can take to adapt your asset to these types of physical hazards? Obviously, the further out you go, the greater uncertainty in the sort of modeling frameworks. Now, it becomes even more difficult when you're tying together multiple hazards. Obviously, if you just focus on one hazard, you can potentially predict shorter range, longer range with greater certainty. But also then you're tying together and you're coupling the uncertainties of multiple different physics models, atmospheric models, biodiversity models. The further out you go, the greater uncertainty we have, that's for sure. This is why we need a mathematical framework that can tie all these uncertainties together. We focus a lot on Bayesian science. We think it's one of the most robust ways of capturing that uncertainty into various models and coupling that together to give a full distribution of uncertainty we have. Because again, go back to making decisions. If someone's going to make $1 million decision on an adaptation, on an asset that's 20, 30, 40 years out in terms of its asset life, you need some degree of certainty, but you also need some degree of uncertainty. How much belief do I have in my estimation of what's going to happen to this asset? So they can make a fully informed decision, because it's impossible to know everything. Almost it's impossible to know what's going to happen to the stock exchange tomorrow morning. Now tell me what's going to happen to the stock exchange in 20, 30 years time, for instance, right? In a sense, that's the kind of uncertainty we have to deal with when you're telling people these are things that will happen to your asset with some degree of certainty in 20, 30 years time. Now, we have the benefit of history behind us. We have lots of observational data. We can see the patterns. I mean, we are living through some pretty harsh times in terms of climate breakdown. People are already beginning to sense this. And I think that's helping people to say, well, if these things are happening now, I actually need to lean a little bit more towards the uncertainty of what's going to happen tomorrow. We have to make decisions under uncertainty. There's no perfect answer and there's no perfect information, essentially, and it will never be available. So the question is, how certain are you as a board, as a company, as an insurance company, as a city planner, to make decisions with uncertainty, with complexity, and living through times of volatility?
In the next few minutes, I'll try and sum up. This is obviously incredibly complicated. Some of the things that I have learned from what you said. The issue is really to start from assets, which the way I'm going to use the word is infrastructure, both physical infrastructure, natural infrastructure, public infrastructure, private infrastructure, and to be able to predict the hazards this infrastructure elements will be exposed to in a time frame of the business decision making. If the business is building a factory which is going to be lasting for 10 to 20 years, in that time frame, that hazard is not one hazard. It's a multiple combination of hazards: heat and heat wave, and fire, and drought, and flooding. And to be able to sort of predict that, today we do have a lot of data out there. It's not necessarily clean, which is why engineering skills are required to scrub it and then perhaps rank it in some form or the other of importance. But along with that, we have the computing skills to be able to put together physical models. But here is where it gets complicated with policy decisions, of possible policy decisions, and to be able to say, okay, in this type of scenario, in the next 10 or 15 years, here is the likely outcome, but within this range of uncertainty. So business managers will have to take one way or the other. As the effects of this start filtering in, one can expect business managers to lean more towards uncertainty, that is to perhaps become more conservative. But that's speculation, of course. That's what I've learned, that we are trying to predict things, actions people can take to adapt to these possible hazards, combining multiple sources of data.
I think that's right. I think one of the ways to look at it is what we're finding with our customers is different clients are optimizing for different time frames. So they're optimizing for different, because we give them the magnitude of risk under different return periods. Then it's up to them and their risk decisions. Am I optimizing for a 1 in 2 year event or a 1 in 50 year event? Or as we saw last year in Germany with the floods, it's a 1 in 400 year event. Actually, different cultures and different businesses have very different appetites to risk. Some people just want to optimize for short-term risk. Some geographies and some cultures which are looking at longer-term risks because they're just better understanding the risk equation. There's a culture of risk management. I would say some of our German clients are a lot more interested in longer range, not just the probable outcome, but the worst outcome. Let's plan for that. It really depends not just on the outcomes of the model, but what is the decision-making framework? What is the appetite for risk? Can I transfer that risk to insurance companies over time? These are complicated decisions. The outcomes of the models and the probabilities and the sort of directional view of where that risk will go then has to be mapped by decision-making frameworks, which is the part of the enterprise risk modeling as well. So this feeds in. This is not a singular risk. I don't expect people to take climate intelligence and make singular decisions. These are bounded by many other variables.
It is, and obviously that has broader macroeconomic implications as well, of course. But I'll end this section by asking you one more question, Iggy, about what I really found interesting in your website is you've done some climate modeling in cities. All the examples that you've given are largely, I guess, private sector. But what are your findings in cities, and what type of adaptation actions are city planners thinking about?
Yeah, so that's a great question. City planners for us are no different to sort of enterprises. They need to look at an asset level across their city and ask themselves some questions. How do we think about integrating adaptation throughout the life cycle of various assets? So most cities build about, well, in the sort of West at least, build about 2 to 3% of net new stock every year. Those are almost easier choices because they can be built for zero carbon and high resilience. It's the stock of assets that have been built decades and decades ago. How do we adapt these assets? First of all, how do we measure the risk on those assets? And then how do we adapt those assets? And how do we think about the right tax incentives? People are not just going to start suddenly spending millions of dollars at adapting assets without some incentive from local governments. We've been looking at various cities. We've been looking at, well, how do we then take climate intelligence into things like city planning? The truth is, Sanjoy, over time, large parts of cities in large parts of the world will be under immense amount of physical risk, mainly from things like heat, flooding, the urban heat islands. What does that mean for efficiency of a city? How do they think about mass transport, hospitals, education, services? A lot of cities are waking up to the fact that they are experiencing some pretty significant changes What does that mean for the vulnerability of the city? What does it also mean long term for the attractiveness of that city from a business point of view, from a living point of view? I think they're early in their journey. I mean, we've seen some great initiatives across cities around net zero and thinking about mitigation. Very little on adaptation. I spoke earlier today to one branch of the UN, and they're now beginning to take this issue of adaptation a bit more seriously, structured at a city level, at an asset level, at an individual sort of facility level. What's going to happen to facility A versus facility B? Again, go back to algorithms, data, and high performance computing. Our ability to look into cities, look at buildings, look at their physical structure, look at their damage functions, and say, well, these assets that were built in this time period with these materials are likely not to pass a certain threshold of risk. These will require some attention. So we just did an exercise. As I was speaking in Dublin not too long ago, we looked at just flooding risk, like a single hazard over a business as usual case, and something like 8,500 assets in the city will be underwater within the next 60, 70 years, right? Just to show the power of analytics at an individual facility asset level, and to say what's the degree of risk that these assets will suffer, just to start having that conversation. And it was both well received and badly received in sort of Dublin, in the sense that you are exposing our risk. Others were saying it's about time you expose this risk, because we have actually long suspected that many of the assets will be underwater under a business as usual scenario. Most people don't want to welcome this type of risk intelligence, particularly at the city level, because it's going to require a huge amount of change, possible taxation, possible tax incentives. But actually, it's an opportunity for green jobs as well. It's an opportunity to rebuild cities which are climate aligned for the first time, which can actually factor in the physical risk that a city is going to live through over time. It's much easier for new cities, of course, Sanjoy. It's what do we do with the great cities that we already have? How do we manage these risks? And that's a deeply complex problem. We are working now with architectural practices. I'm sort of happy to say we are working with planners and sort of planning software so they can factor in the physical realities when they're designing new buildings for the first time. I'm very pleased with the client that we've just got recently. They're one of the preeminent architectural practices in the world, and they have long overlooked this issue of physics. How do I put physics into the design phase of a building? How do I model out, okay, will this new architectural building withstand a 2.5, 1.5, 8.5 scenario for different hazards, for instance? They need to factor that in now, because these are knowable events with some degree of certainty. So of course, if you're going to put up $100 million new real estate building or a hotel or public infrastructure, you can factor in what's going to happen from a climate risk point of view and say, am I building it in the right way? Can I strengthen it? Do I need to fortify the foundations? Do I need to build barriers next to these things? These are knowable problems today. So let's not put up low resilience infrastructure in areas that are likely to suffer from significant physical changes in the sort of coming decades. Remember, we always say physical risk is locked into the system. So all the historic emissions have stored up heat and energy, and that will get played out in the next 5 or 6 decades. And until we can get to net zero and negative emissions, that physical volatility will just get worse and worse. And it may reach tipping points. We don't know yet, Sanjoy. No one knows what's on the other side of those tipping points. We can tell you today that high degree of certainty, physical risk will only get worse and worse in the next 5 or 6 decades. At the time, there'll be much more sophisticated views of entire supply chains and value chains. Then the markets will start demanding that as a baseline. Today, they're demanding a broad declaration of what is my climate risk. Tomorrow, or in 3-4 years' time, they'll be demanding very sophisticated views of what is your codependent risks within your networks of assets, B2B partners, funders, exposure to different countries, for instance, exposure to different hazards. And also, remember, disclosure is also concerned with transition risk, not just on this sort of physical risk side, it's also on the transition. What's going to happen to your assets in terms of, are you going to suffer orderly, disorderly changes, disruption to your business model because of changes in policy, technology, or market prices, also just some radical breakthroughs. All that needs to be fused together in a disclosure report. And again, very, very complicated, because you're dealing with variables that you haven't really calibrated in your risk models, you haven't reported against before, which is why I think particularly public companies have been quite nervous about disclosing their risk for the first time to say, well, what do we do? What level of granularity do we offer the market? And the regulators are giving some latitude in sort of not setting too prescriptive areas. I think they've given about 11, 12 different areas which people are giving you best practice, but they're not making it prescriptive that you have to do it in a particular way today. Unlike financial statements, which are very, very prescriptive. There's certain things you can and cannot say. It's a rules-based system. I think climate disclosure right now is not really a rules-based system. It's a large ground for you to declare directionally what's going to happen to your climate risk. But I think that will change, Sanjoy. Next 3 or 4 years, we'll have the exponential tech, the machine learning frameworks that can start looking through beyond broad declarations of climate risk into asset level risk and also connected risks.
Right. Actually, Guy, I was looking at some of the disclosures made by the financial institutions, and I cannot agree with you more that the variation of disclosure. And I just understand that people need space and time to learn. And I think that's really what's happening.
I think so. The variability we see today means that you can't compare security A to security B. There's some certain guidelines that we look for, like, are these standardized? Can you repeat that experiment every year on your sort of methodology? Is it verifiable? Is it objective and unbiased? So over time, I think these disclosures will have to abide by some of these rules, because as a few companies do it, then the market can say, well, these companies are disclosing a lot more information at a granular level. They're also disclosing their connected supply chain risk. Actually, this should be the template going forward. It always takes a few pioneers in every sector. And I think we're likely to see that amongst some of the listed companies, people who are disclosing faster as a form of competitive advantage as well over time.
Exactly. You brought up this point about supply chain a couple of times, and I wanted to understand, obviously, supply chains in today's world has become increasingly globalized. Now, of course, we know that the pace of globalization has slowed a little bit, but it's not stopped. And so how, is it possible for companies to look at their global supply chain and do analysis of risks that we talked about?
This is precisely what we want them to do. It was surprising to us that they voluntarily wanted to look at their supply chains, because our initial use case was very much around baselining their own risk on their own assets for their internal reporting. Well, it didn't take them too long to figure out, actually, can I look at my suppliers next? So we have a large retailing client, for instance. They are now looking at their top 75 suppliers and sharing the intelligence with them. Because ultimately, once you can share the risk, you can take collective effort to figure out, well, how do I adapt to this risk? How do I address this risk? How do I understand this risk? How do I have that B2B conversation for the first time? This is one of the reasons we don't just do modeling. We don't just model stuff out. We actually think about, how do we create network intelligence over time? This is why we've actually pre-populated our platform with millions of, actually now hundreds of millions of assets, so people can build portfolios of most critical suppliers in different parts of the world, and they can measure the risk on those assets as well, on their asset. That becomes really important when you have supply chains that are highly dependent on variables like nature, water, rising temperatures, greater flooding. All that then impairs your business efficacy, right? What happens to your business continuity if 15 of your suppliers, which are geographically concentrated in one area, they suffer from flooding? Let's say you had components coming in from Pakistan, for instance, over the last month or so. We've seen some terrible episodes of what's happened there. So it allows companies to start thinking about, well, how do I diversify my suppliers? Now, not every supplier can be moved, Sanjoy. If you own a mine, for instance, or a cobalt mine, you can't move the mine. You can't move things like coffee production. But the question is, can we have those B2B conversations? We can say, can we think about joint adaptation? Because I am dependent on you and you are dependent on me. So given that, can we adapt these assets together? Can we figure out what is the extent of physical risk? Do I need to build more barriers? Do I need to think about HVAC systems? Do I need to think about diversifying my supply chain? All this then feeds into decision-making processes at the enterprise level. But supply chains are critical, because I think you're right. We have optimized for cost over the last 50, 60 years, and often at the extent of resilience. We haven't optimized for the right resilient supply chains. We've optimized for the least cost supply chains over the last 50, 60 years. And that's biting us hard, because the distribution of climate risk disproportionately fall on areas which have low costs. That's, and that's only going to get worse, Sanjoy.
Right. I'll try and sum up this section a little bit in the following way. I can sense that there are some key reasons companies are coming to you, private sector companies, Obviously, one reason is the disclosure requirements. And today, I'm almost tempted to use the word, they're crossing the river of disclosure by feeding the stones. I mean, they're exposing certain things, learning, and so on and so forth. But one of the things that you said will stick with me, which is people are asking you, is it an event or is it a trend? And people are tempted to think that it's a trend, and then they're asking deeper questions. What happens to my global supply chain? What can I do to make myself and my supplier more resilient? What am I going to do across countries? On the public sector side, I'm sensing that there is both fear as well as excitement about what we can do, and fear of what I stand to lose in some ways.
Right.
But again, the example that you gave about somebody building a large building or a public building or a hotel, thinking about the risks that you have to build against for the next 20, 30 years is probably what you call low regret, things which you have to do anyway. So that's the way I'll sum up this, applications of your modeling in real life cases.
Just one extension of that is, if you look at the last 5-10 years and look at what's happened in digital data, in modeling capability, machine learning breakthroughs, and say what's going to happen in the next 10 years, then we can no longer say that climate doesn't cause disasters. It's actually vulnerability that causes disasters over time. If you can measure better, and you can then put that into the public realm and put that into decision-making frameworks, then actually you're choosing disaster by choice over time. Climate does not cause disasters, vulnerability does. And if we can measure the vulnerability, then you can make more informed decisions. And if you don't make those decisions, then that's a choice. And sometimes you're going to have to live with those choices.
Iggy, I probably never heard a more wiser phrase that you brought up just now about how vulnerability creates risks. And coming from the emerging world that I come from, Asia and Africa, where I've worked, I can see this so clearly, vulnerability that is caused by the local damage to the environment as opposed to the global climate change issue. And then vulnerability that is caused by socioeconomic inequality, gender issues, and so on and so forth. We will move on. We'll end by talking a little bit about your business. You're a certified B Corp, right?
Yeah.
What does that mean practically?
And practically, it means we brought together a collection of fantastically talented people who want to marry mission in their everyday work. And we've sort of codified a bunch of business values, or sort of company values around objectivity, community, integrity, humility, curiosity. And that kind of underpins all of our policies, everything from our environmental footprint, of course, as a sort of climate tech company. We also think about welfare of people, the training of people. It's a codification of multiple areas. And then there's an independent body that scores every B Corp company. So you have to maintain and score a certain level. It takes about 2 years to get the process done, but it's worthwhile if you want that codification of those values. And I think that helps us across the firm as a B Corp. I think we're generally quite mission-driven folks. In fact, my previous business was a mission-driven business as well. So I was very keen to get the B Corp for this. It galvanizes lots of people internally, helps us attract great talent. And I think it, by default, and hopefully in the future, businesses will just behave like B Corps over time. They won't need the certification. Today, it's a form of differentiation over time. All businesses should be thinking about their stakeholders, the way they treat their employees, the way they think about their carbon footprint, their energy usage, and how they work, how they reward people. All that plays in. I think we have a score of around 104 or something. So it's a reasonably high score as a first-time B Corp, and we'll fight to make sure that we can maintain that.
Let us talk a little bit about your team, which is obviously anybody who has listened to the previous part of the podcast will understand is an incredibly talented team.
It's talented, it's multidisciplined. I always say that in any ordinary company, you wouldn't need to bring all these skills together. But when you're tackling things like climate, you have to fuse together many different disciplines and that includes from all the way from business to software applications to academia to research. And that presents challenges by itself, but then you have to think about what does a unifying culture look like? How do we work together? How do you get a researcher who's been in university for many years to work together with someone who has delivered client products before, right? That's a learning process, and that doesn't happen overnight. And we've been at this for 6 years now. It takes time. Initially, when we first started, it was really a cultural research, experimentation. Then we moved slowly towards product, and now we're moving towards a user-centric and a customer-centric firm. And You have to carry people with you all the time. And that's hard. We've also underpinned the company with what we call the Climate Intelligence Council. And we've drawn upon people from the science world, from the policy world, from the business world. We've managed to bring on the former head of the EPA from the US. We brought a former number 2 from the NSA, from the States, because climate is also a security problem. We will carry on bringing people who can add significant value, but they fundamentally understand that climate intelligence is a new discipline that needs to be codified in every decision-making process across a firm, across a government, across a local government, with some urgency and with a degree of transparency as well. They've been very vocal for us. They've been hugely supportive, and they've opened up networks which has allowed us as a small firm in London to have meaningful conversations with policymakers.
You briefly alluded to your previous company, which was in Africa, a mission-driven company, and you are not a scientist. What is it like being the CEO of a company which is full of scientists, and I believe one Nobel Prize winning team as well?
That's right. Very humbling because this problem just demands incredibly smart people. Previous company was very helpful for me in terms it shaped what kind of company I wanted to build next. My current COO, Karen Chopra, was the co-founder of the previous business. So we built an integrated sustainable rice business in West Africa. And we could optimize for everything. We can bring the best technologies, the best seeds, the best sustainability water management practices, but we couldn't control the climate. We couldn't control extreme events. We got really frustrated because 3 or 4 of harvests just got taken out by these extreme events. That was the genesis of experiencing that firsthand that gave us the idea. And I went on to sort of build that Cervest around, okay, I need to change the relationship between climate change and my business decisions or my farming decisions. And that was the genesis of the business. How do we get greater signal? And how do we take all that complexity in all these various models? I mean, when I first opened up a climate model years ago, I think it was 2014, right? It was just deeply complex. I said, there's no way I can do this without massive help. And I turned to people like Dr. Ben Calderhead, who was over at Imperial. He happened to be a Bayesian expert. The first, I hired a lot of mathematicians first and foremost to say, is this a maths problem? Why can't we link all these models together? Why can't I take this down to the asset level? So I'm very good at asking the dumb questions, and then I find the smart people to go figure out the answers.
There is discipline called management, right? And I'm just wondering, not many people have the experience that you have of coordinating and managing the activities of extremely bright people working and absolute specialists in their own subject, to be able to put them together in a room and get them to achieve a really big goal. In some ways, I can think of a football coach, maybe, but I'm just thinking from your experience, what is the management insight?
I think it's complex. You have to look at what unites people inside of Cervest. And it's really around the mission, the vision. Can we democratize climate intelligence so everybody can use it over time? And it's a burning problem. There's many people who can probably treble their income overnight if they went and walked across the road to Google or would DeepMind or sort of place like that. But I think they're here because they like the purpose. I think purpose-driven businesses in and of itself actually binds lots of the culture together. And then on top of that, we have codified this as a B Corp. We spend a long time on how do we build a culture. In the first 3 or 4 years, we had so many workshops in terms of what kind of company do we want to build? How do we think about management? Not in the classic hierarchical sense. And I'm more of a flat hierarchy person generally. So I would say the last year or so, we've started building a new raft of management team at the very top. We brought in people like Matt Vandersee recently. He was a VP engineering at UiPath. People who have seen scale, because I think it was Karen when he joined me again last year after 5 years of being a senior advisor. He said, we have to marry mission with method. Right? It's no point being high on mission and having no method. And it's no point being high on method when you're trying to tackle this type of problem because you need mission-driven people. How do you fuse together our sort of M&M machine, mission and method in ways that are practical that can ultimately drive a business? We are a for-profit business. At the end of the day, we do have investors. I do have boards, and they ask very penetrating questions. So of course, you have to design a culture which is driven by markets, business strategy. Can we be the best platform in the world? world? Can we also offer a fantastic service to our customers? Like, can we give them new insights that they don't have before? And all that needs to feed all the way from the product team, from the scientists to the engineers, to the front-end engineers. All those teams need to come together. So we've moved a lot more towards mixing scientists and engineers together into teams. And that's been pretty successful for us. It's been a change. It's been a lot of change management over the last year. A lot of that has been driven by Karen. But I actually think we're seeing the fruits of that now, because even when I talk to some of my scientists now, they're talking to customers, which is exactly what I wanted them to do. So customers can ask the really hard questions, and we have the best people answering those questions. Culture and management it's a learning process. This is my third company, and each one is very, very different. There are some common patterns. A lot of that is around not having too much hierarchy. I mean, for me personally, but hiring very competent people who have seen some of this before, Sanjay. I don't think there's any easy out-of-the-box answers. I think most climate tech companies that I know are also trying to fuse together all these complicated talent sets and skill sets. And I talk to CEOs of other climate tech companies. It's the same type of challenge, because I think entrepreneurs want to go and build the greatest business, but the climate problem, whether you're tackling carbon removal, or climate analytics, carbon accounting, you need to fuse many different skills together for the first time. And it's hard. It's hard because there's very few playbooks. There's very few great examples of how climate tech companies should be built, can be built, and how they can scale. Not many have scaled so far. It's still very, very early days.
One of my previous managers used to say, hire talented people and get out of their way.
That's right.
Exactly. I'm going to ask you again, any final message that you want to leave for our audience today?
I just say the question of climate is a complex problem. I do urge people to accelerate their understanding, become more climate literate, because I think the surface area of risk has fundamentally changed. And I think your relationship with climate has to change. You have to embrace it. You have to understand it. It's really interesting. When we first brought on some initial customers onto the platform back end of last year, they were gingerly settling around the platform, and we were gingerly trying to figure out how do we explain these complex concepts to them. Now we bring on customers and it's become a lot slicker all of a sudden. Like, we have figured out what the pattern recognition, like what works well for a mid-level manager, senior manager, a risk manager, ESG manager. So we can drill down a lot faster. I think we've had a couple of iterations of the product over the last 2 quarters as we've learned from how are people absorbing climate intelligence? How are they thinking about it? Where are they using it? Where are they getting stuck? So my message is your relationship with climate, whether you like it or not, Sanjoy, will change. Therefore, it's incumbent upon you to understand those risks, become a lot more literate, and understand how can I embed that into my decision-making framework. Because we can't go on ignoring climate. I think we've done that for far too long. And I think climate will change in ways that I think will force people to change. And I think that's what disclosure really is. It's like an institutional forcing to say, you need to wake up to this risk, whether you realize it, don't realize it, want to realize it, believe it's man-made or non-man-made, almost doesn't matter. You need to confront it.
And if people want to get in touch with you?
Yes, so if anyone wants to reach out to Cervest, we can be reached at www.cervest.earth and send us an email or log in online, and we can get one of our salespeople or one of our BD people to connect with you, have an early conversation with you.
Thank you very much, Iggy.
Yeah, absolute pleasure, Sanjay. Lovely talking to you.
On that note, thank you very much. Follow me on LinkedIn, Medium, and Twitter to get fresh international perspectives of what people across the world are doing in this decade of climate action.